Okay, so for part 2 of our attendee notes video lesson, I wanted to talk about different things you can do in your calculator. This question, annoyingly, asks us to identify z-scores, but then also asks us to find the probability. I don't need to identify z-scores to find the probability, but since it asked me, I'm going to have to do the z-score. It also says, next, enjoy that you won't have to look it up on a table. Yeah, we used to have z-tables, and you had to find the score. It was very annoying. Now we have our handy-dandy calculator. So again, I'm going to start by drawing my picture, always. I'll just draw it in the middle because I'm going to use it for both pieces. And it says the average number of calories in a chocolate bar is 225. And then it's normally distributed with a standard deviation of 10. So I'm just adding 10 on the right, and then I'll subtract 10 on the left. That's a nice, easy number to work with. How nice. So these are my actual x values, and then, as you know, my z-scores are going to be 0 and 1 and 2, and -1 and -2. And then it says, find the probability that a randomly selected chocolate bar will have less than 200 calories. So that's going to be a really small probability because it's going to be to the left here. So I'm going to say 200, and then I'm going to go to the left. And so you know that it's everything to the left, so basically I need negative infinity over here. Now, you could find the z-score associated with this. It's a little bit to the left of -2. So z-scores, I'll use my formula, and z equals, what was it, x, the x value minus the mean, which is 225, over the standard deviation, which is 10. So that's -25 over 10. So that is -2.5. And you probably could have guessed that that was the z-score. So now when it says find the probability, I can use what I was doing before, like in the warm-up, and I can say normal CDF from -infinity or something close, like -1 and a bunch of zeros, like -10,000, -100,000, whatever, to -2.5. I can put that in my calculator with a mean and a standard deviation, mean of 0, standard deviation of 1, because that's using the z-scores. Or I can do this fancy new thing where I don't even care about the z-scores, and I can change the mean and the standard deviation when I do my normal CDF. So I will go normal CDF. The low is -1 with a bunch of zeros. The high is 200, so now I'm using actual x values. So I'll use the actual mean and the actual standard deviation. And when I put that in my calculator, I'm going to get the same thing either way. So I'll show you on the calculator how that looks. Let's move the calculator over here so we can see what we're doing. Oh my goodness. Okay, it doesn't want to get any smaller. So the lower, I'm already on normal CDF, so the lower is -10,000. Oh, I didn't go negative. Negative. Oh, my computer is being so crazy right now. 10,000, 100,000, million, whatever. And the upper is going to be, what I say, -2.5. So this is the way that I can use the z-scores. And then if I wanted to use the actual data, I could go to normal CDF, and I could go -10,000 again, because I want like negative infinity basically. But my upper is 200 calories, and now my mean was 225, and my standard deviation is 10. And so when I paste that, and people with a older calculator like mine, this is just what you have to automatically put in. Like, you have to remember what to put in your calculator, unfortunately. But you'll notice that it gives me the same thing either way. Oh, geez, didn't mean to do that. It gives me the same number either way. So the answer is going to be, for this one, negative, or sorry, 0.006. So the probability, no matter which way you do it, is 0.006. Sorry, this was calculations from the last guy. Or 0.6%, which makes sense. It should be really small. If you recall, this spot here is like 2.5% to the left of 205, so this is much smaller even. Okay, and then to do part B, I'm just gonna clone this page so I have a little more room to work. And I'm just gonna like erase some stuff here. All right. So now we're talking about, oh gosh. All right. So now we're talking about between, what's the probability that a randomly selected bar will have between 220 and 240 calories. Sorry. All right. So now I'm talking about, oh, I gotta get rid of one more thing here. Between 220 and 240. So between 220, terrible line, and 240. So again, you could use the z-scores of -0.5 and 1.5, or you can just use your lower, upper, etc. So we're going to use normal CDF. My lower is 220, my upper is 240, my mean is 225, and my standard deviation is 10. So I'll go ahead and put that in my calculator. So to put that in your calculator, and again, if you have an old calculator, what you're going to end up with is what happens when we paste it. So if you have a newer calculator, they try to make it easier for you, which is great. Older calculator, you just have to remember the thing we wrote is what goes in the calculator. So low, high, mean. The mean and the standard deviation are the same as when I did the part A, so that's good. That didn't change. And so then I get 0.625, or 62.5% of the probability, or of the data. Okay, so the probability that a candy bar you pick will have between 220 and 240 calories is 62.5%. There's a 62.5% probability that that is what you will choose. All right, so for these guys, again, the main thing is to draw them. And so I'm just gonna kind of walk through the key that's already done. So the average price is $9.49. They're normally distributed with a standard deviation of 100, and the probability that it costs more than 1,200, I'm just gonna put 1,200 on there and shade to the right. So what's the probability that it's more than 1,200? So because again, I have word problems, now I have more to this thing. So I'm going to go normal, I'll move this over so you can see the whole thing. I'm going to go normal CDF, and my lower is 1,200. My upper is infinity, so you can just put in 1,000 or whatever. The 1E99 means 1 with 99 zeros after it. And remember, you can do that by saying, it's over here. I'll show you. So 1 and then the second comma. That is scientific notation. 1 times 10 to the 99th. And then your 949 is your mean, and your standard deviation is 100. If you put in a 1 with a bunch of zeros for upper, you're still going to get the same answer. And so we get 0.0060. And then to look at the next one, the average admission cost, so that's your mean, is $5.39. Normal distribution, 79 cents. And then what is the probability that it costs less than $3? So that's to the left of $3. So we go negative 1 times 10 to the 99th, or negative 1 with a bunch of zeros. And then upper bound is 3, 5.39, and 0.79. It's about 0.12%. Okay, and then I wanted to just talk to you about these middle of the road problems, because we actually have another way to do it now with our fancy new calculator. So if you have an old calculator, you actually need to do two problems here, but this one's actually telling you when it says 50%, that is actually giving you the probability. So these are the problems where you're given the probability or the area. And so they're the opposite of what we were just doing. So these use the inverse norm because they're the inverse function of the normal CDF. Okay, so the one way to do it is to do the inverse norm with the low. And this is another Beyonce function. We always go to the left. So the left 25% or the left. Now this guy, remember all the area under the curve is 100%. I'm just gonna show you a new graph for a second. If we're talking about a curve, remember that all of this is 100%. And remember that this part is 50% and the other part is 50%. So if I'm then talking about the middle 50%, that means 25% on this side of the mean, on the left of the mean, and 25% on the right of the mean. So if I'm talking about that's the part that I want, is the middle 50, but I'm using my Beyonce function, so I'm trying to find like what is this X value and what is this X value? To the left of this guy is 25%, because I already have 25 and the left half of the graph is 50%. And then to the left of this guy, that was supposed to be hot pink. You know how I love my hot pink. To the left of X2 is 25% plus 50%. So that is 75% to the left. So that's where these numbers come from when we're talking about the old school way of doing it, which is the 25% and the 75%. And of course, remember, we always put the probability in here, but now for inverse norm, instead of just putting the probability and a 0 and a 1, now we put our new mean and our new standard deviation still, so that we can actually get X values instead of Z-scores. So this is the old way of doing it. The new way of doing it, I'm gonna pause this for a second. Okay, so the new way of doing this is with your calculator, you're gonna use that center part of your inverse norm. So this is only if you have a new calculator. If you have an old calculator like mine, you gotta do it the old way. I'm so sorry. By the way, I don't know if you guys noticed, but I put a link for an online calculator like this one. TI is letting people use it for free because of all this schooling from home. Okay, so I want the middle area to be 0.5 because I want the area that's the 50% in the middle. And my mean is 225 because this is the chocolate bar problem. And my standard deviation is 10. So the center part is when you do the middle 50%. And so what it tells you then is that your left Z value, or your, I'm sorry, left X value is 218. Get my pen here. Is X1 is 218. Hello, pen. I don't know why it doesn't want to write. 218.255, so 26. So that's my X1. And then my X2 is going to be the 231.6. 0.74 calories. So that's what I have here and here as well. I'm doing it the old way, but if you have a newer calculator, it is so, so nice. So that's how you do the middle curve. And then I just wanted to show you, I'm not going to key anything else for you, but just like what is the lowest price associated with the top 15%. It's easy to go the wrong way on that, so just make sure that you're going the right direction. This one had inverse norm 0.85, which is, that's what is to the left, because again, with the old way of doing this, this was the Beyonce function, so it's 85% to the left. But again, with our calculator, you could do it a new way by using inverse norm and using your tail to the right. You could do 85% to the left, or you could do, what was it, 15%? 15% to the right, and the mean was 949. Let's do this. The mean was 949, and the standard deviation was 100. And so now I just want my tail to be to the right, which we talked about in yesterday's video. And so that is another way that you could do that. Instead of using the left, you could use the right. And look, you still end up with the same thing, but note, this is money, so I am gonna round it like dollars and cents. I think that's really all that I wanted to show you. I think that I've shown you most of it here. Again, this one is a middle 60% of the market. So that's really nice, really easy to do on your calculator. But please do be checking your keys as you're going. So let me know if you have any questions. I'm around. Take care.